Welcome back, my friends. This is Karthik Nagarajan, your technology buddy. Today, I would want us to discuss about two important concepts. One thing is context, and then the other aspect is context compaction. What is a context? The thing is, AI models and any communication with the AI model doesn't hold a memory, which means whatever we are going to ask an AI model doesn't understand what we are asking with the past historical communications. It only understands what you're asking, so it is stateless. So it understands only the current state, it doesn't store the states. So if you have been asking for, let's say, multiple questions, then it doesn't know all the historical details. That is the secret behind the AI model. And then the reason why we are using the AI model very fast, because you just ask, it just responds. Now, there are scenarios, and all our scenarios as of now, whether we are building an application, whether we would want to ask for a data from our existing data sources, or whether we would want now to ask about our historical charts or historical discussions, these AI models doesn't understand what you're asking from the point of view from your historical data. So now let's see. That means whenever we are going to question the AI model, we need to push all our historical details along with what we are asking now, forming that as a context. So that is the thing that we have to think about, because if you push a lot of information, all your credits are gone in the tokens. All the AI models, the LLMs and all the AI models, they calculate tokens. Now tokens are calculated from the bytes and bits of memory that we are given. Now with OpenAI and Gemini, you can now pass on like a 9-word string where you capture it as 4 characters on average for each word, and then you pass it on to get a response. You will find that the tokens consumed for the 9 words is like almost 10 to 12 tokens in Gemini. And then when we go into the OpenAI, let's say OpenAI, when we get into OpenAI consumes like 14 to 16 tokens for it in each and every AI models. That's what we understand. Now, what are we speaking about a token? Token comes from where? What is calculated? The calculation is based on what we give as input. Anytime there is a historical data that you have to pass, and then the actual question that you have to pass together for the any AI model LLMs to understand the context of what you are discussing about, the aspect what it has to think through, and the focus that he has to take in to respond in that tone or in that aspect or in that for to respond for that purpose of that question. So now we understood that not just a question that we are asking or the chat that we are communicating goes in, along with it all the historical data comes in. So the context window, this makes the AI models or AI apps to be breaking. This makes it break because the context window is limited always. It is not all the LLMs or all the AI models are allowed for unlimited context window. There are limitations for each and every AI models. And then the long chats push old chats info out. That is, the latest one goes in and then the past one goes out. The thing can happen is it might assume, it might contradict. So that is what we call hallucination. So now the AI model can hallucinate and get you a funny response or a wrong answer or something out of your perspective. So then the most important fact about your communication might get lost. So that is very important. And the next thing to understand is this context window, as much as you use the context window even fully or beyond the limit, you are going to consume a lot of token. So each prompt consumes token. That's what we have to understand. So what are we looking at? Why are we discussing this today? Because the context is something that you are passing on as a request to the AI model for the AI model to respond. Now, how are we going to question? Because if we are to give all our details, and all our details are too huge than the context window, what we call it's a context window. Beyond the context window's limit, if our request goes beyond it, for sure we have to understand our data is going to be slashed in and thrown out. So our data is not going to be consumed fully for the system to think and respond. So what we are coming into is a concept called context compaction. Context compaction, what does it mean? You just take what is important for you, and then now don't just dump in all the historical data. So pick from the historical data what is important and then choose it selectively, so the context of the history remains. Let's say the perspective of the history, the understanding of the history, the theme of the history, the essence of the historical communication remains in your current question or your current chat or your current request. So the current request is added with the historical essence, not the dumped data. So that is what is called context compaction. I wouldn't want to go so deep into that, because what is context compaction? Context compaction is very important because it reduces the prompt size without losing meaning. One thing, keeping business critical information in every of your request, and then removing the noise, repetition and history, because you might have discussed about the same item again and again and again. So there is no need for you to dump in all your data while you are now requesting the AI model. You don't have to do those redundancies, add those redundancies in your. So do a context compaction process and then reduce it, shrink it to what is the essence of the history, and then add it to your request and push it for the AI model to respond. That's going to be the best. So whoever is working with the AI models, whoever is leading a team who is working with AI models, whoever is now building an application that now goes into AI models to respond and to request and get a response, now guide your team to go through context compaction. And there are libraries and tools that does the context compaction, so that let them use it. By involving those tools, each and every of your request reduces the noise, reduces the redundancies, and reduces the unnecessary things, while you keep always the essence of the history. While you are requesting, you are not consuming your tokens and you are not paying a lot. You will hold on to your paid tokens in OpenAI or Gemini or whichever the AI models you are using, so that you can now go for many requests. So what in short is maximum meaning, minimum tokens? Let's just give it one line. You can go with maximum meaning, minimum tokens with the context compaction technique. Now, what should always stay in the context? For example, assume let's now think about an ERP. Now, for you to now use the whole ERP database, and then you are now going to start questioning whatever is in that ERP database. So just think about it. For an ERP, just go with the record IDs. Is it an invoice, PO, employee ID? Then amounts, currency, dates, current status, workflow state, approval and policy constraints, user role and permissions. Just pull this and then now keep it in your context history, which is one way of context compaction, for example. And now what should be compacted? Old conversation history, repeated explanations, long discussions and clarifications, historical emails and chats, old decisions already finalized. You don't have to go with it again and again. So this is context compaction. Now, how will we be able to do context compaction techniques? Now, there are lot of context compaction tools you can still use. They are inbuilt in those tools. For example, LangChain summarizing memory. LangChain allows you to summarize memory. Then Llama Index, that has node and summary index. Using that you can do compaction. Then we can write custom Python libraries or Python coding. That is a different thing. And then token based compaction triggers. So all these, because you know for what the token is used. So which means you can now see that whatever you have pumped in and how many tokens have been consumed. You can check always whenever you request, and when you get a response, you can confirm the tokens consumed. So with which you can even say which data is consuming a lot. So I take that as priority for me to compact. In my research, I realized context compaction made me to spend less tokens in my AI applications, because even though we have our own LLMs, we can have our own localized LLMs for which we can now use the local LLMs without spending a lot. Question comes in, if we push a lot of data into our request, even if it is a localized LLM, it is going to take a lot of time. It has been taking a lot of time. So in our R&D is where we have implemented various of items on these discussions, whatever we have been going through for several weeks. So now the point is, with context compaction, I am able to now compare the local LLM utilization and also the token utilized by the paid AI models, and I realized it has reduced a lot. Thank you, my friends. Thanks for listening to me. Thanks for your precious time, and take care. Cheers. Bye.